Hello, everyone. Good morning, good afternoon, good evening. Thank you so much for joining us today. My name is Rigo Villa. I'm one of the community managers on the Cisco Learning Network, and I'll be your host today. In this session, we're going to be covering Zero Trust Industrial Operations with Cisco Cybervision and ISE with our speaker and presenter, Andrew McPhee. But before we get started, I wanted to share a couple of quick housekeeping notes. First, I want to let our attendees know that this session is being recorded and will be available on demand within approximately 5 business days after today. Next, I would like to take a moment to address our Q&A for this session. So we will be using Slido for any and all questions during the live event. So please feel free to submit your inquiries and one of our amazing panelists will be ready to assist with your questions. Additionally, we will be launching a survey on Slido at the end of the live stream, and your feedback is very valuable to us. So if you can just please take a moment to fill it out and share with us your thoughts, we would really appreciate it. Also, for your convenience, you can find a list of ICE resources on the left side of your Slido window. And one important note about Slido is that it's only available for the live audience. So if you're watching this session on demand, you won't be able to submit any new questions through Slido. So it's just something to keep in mind as you're watching this session at a later time. Also, if you haven't done so already, you can go ahead and scan that QR code on your screen with your mobile device, or you can log in directly through our ICE live streams page. This ensures that you're ready to engage and submit your questions at any time. And finally, I'd like to share a couple of our exciting upcoming events. Our next ICE session is going to be Data Connect Deep Dive. That's scheduled for Tuesday, March 4th. And following that session, we will have a new expert presenting the ICE update on Microsoft Security Identifiers. That's going to be on Tuesday, April 1st. And lastly, on May 6th, we're going to be covering ICE certificates with Let's Encrypt. We invite you to join us for these sessions. If you haven't done so already, you can register using the short link on your screen, or you can find it on the left-hand side of your Slido window under the resources as well. All right, so without any further delay, I'd like to hand it off to our expert and speaker to get us started. So, Andrew, welcome, and please go ahead and take us into the topic today.
Thank you. So hello, everyone. My name is Andrew McPhee. I'm the Industrial IoT Security Solution Manager here in Cisco and look after our architectures for secure and critical infrastructure, whether that's manufacturing, utilities, transportation, or any of these other kind of verticals that we're going to speak a little bit about today. And the topic is zero trust for industrial operations, specifically using Cisco Cybervision and how it integrates with ICE. This is a kind of a smaller session to what I'm doing at Cisco Live. So if any of you are in Cisco Live Europe, you'll get to hear me speak about this for 90 minutes. If you can't make the session, but you're on Cisco Live, just come find me. I'll be somewhere in World of Solutions over at the Industrial IoT session or section. So the agenda for today is I want to give an overview on just Cisco's approach to industrial IoT security in general. Segmentation and zero trust is one part of more holistic architecture. So I want to kind of show you what that looks like. But I'm going to go through some industry recommendations for segmentation. You know, it's no use me just telling you how to use specific products, but what an industry trying to do and how does Cisco map to that industry recommendation. And then I'm going to talk about a concept called virtual segmentation, because OT networks are quite unique compared to more IT networks. And sometimes we come into this late as an IT team and we need to get an understanding of what's on the network first before we can do enforcement. And then using the network itself as the enforcer, the real kind of, meat behind why we're using ICE today in this session. So for those of you in the OT space, there may be some of you on this call, others may be here listening just because you're interested in IoT. There's a difference between industrial IoT and IoT. When we think of IoT, we think of temperature sensors and connected coffee machines and your smart fridges. Industrial IoT is essentially critical infrastructure. It's the stuff that makes the world work. It's our manufacturing plants, it's our utility grids, it's our railways, it's our mines. And that's what we mean by industrial IoT. And Cisco has been connecting these for well over 2 decades now, bringing in ruggedized switching equipment, ruggedized routing equipment, and then overlaying security on top of that. I need to shout out wireless as well. And for those of us in the space, it's no secret that we have very poor network hygiene when it comes to industrial IoT. The networks are quite old, the machines are quite old. The same production lines that were built 20 years ago may still be there doing the exact same thing it was doing when it first was operational. And there's not much patching or updating or really any cyber hygiene that happens. And now we're being connected. And with this connectivity, attackers are really taking advantage of it being done poorly, because we need to connect data to data centers, we need to start connecting to clouds, we have remote workers, and all of that is requiring enhanced connectivity inside these plants. But we don't have the security foundation in place that we did in IT to really stop these cyber attacks from happening. And in 2023, the world's critical infrastructure suffered 13 cyber attacks every single second. Now, they weren't successful, otherwise we'd be in much more kind of trouble than we are currently in. But the number of successful attacks are rising quite exponentially. As you can see, there was a small blip in 2017. For those of you, again, in OT, you might have heard terms such as like WannaCry. That's when that ransomware came about. But as big as WannaCry was, you can start to see the number of successful attacks are just exponentially growing, and especially during the pandemic and when things went to remote work, we had much more poor connectivity happening. So we do have a more holistic approach to secure this. Zero Trust is one element, quite a big element, but it's called Cisco Industrial Threat Defense. And we use that network as the kind of foundation to everything that Cisco does, because the reason why we're in this position is because of connectivity. So your security starts with your connectivity, starts with your connectivity choices, and how can we use the network as the security fabric across the OT. So it starts with visibility, understanding what is on our network, what is connected, what the relationships are between devices, what are the vulnerabilities that we have. We know we have a weak posture, but we don't exactly know what it is. There are stories that I'll get from customers when you speak to them and they do what they call a line walk. So an IT person and a security person, they'll go down and just do an inspection of the line, see what's connected, see their kind of current posture that they have. These aren't the folks that spend every day on site. And it's funny what they'll come across whenever they actually walk the line. I think it was just the Christmas period gone, maybe it was the Christmas period before, I forget when I had this conversation, but there was an IT manager that was going down the line post-holidays, and they saw an Xbox connected into one of the switches that also connected one of the production lines. So those workers were a little bit bored over the holidays. So they see things that maybe shouldn't happen, and we need a way to do this automatically. We then need to take action on that visibility. So from a kind of cybersecurity perspective, visibility is great. It's great to understand what's on your network. It's great to understand who's connected to your network, what it's doing, but you want to take preventative measures. And there's a zero trust strategy that Cisco's really trying to help our customers go down in the operational technology space. The first part of zero trust, which is going to be out of scope for this conversation, is zero trust network access or remote access. Cisco Secure Equipment Access is the product that we use in this space. We have a dedicated product for remote access into OT networks, things like scheduling your access. So the vendors only have access for a certain period of time. It's not an always on VPN solution. MFA by default, and making sure that you can record all of the sessions and monitor them in real time. We have a solution for that. But the bigger part of zero trust is, and what we're going to talk about today, is Cisco ISE. And there's a standard we're going to talk about in a couple of slides from now called IEC 62443, where we'll see how Identity Service Engine is actually kind of a perfect tool for implementing best practices in segmentation for OT. And then lastly, there is a skill shortage, both in the security space, both in the OT security space, especially in the OT security space. So we can't afford to give more tools to these operators to learn. We can't say, here's another dedicated OT visibility tool, another dedicated segmentation tool, another dedicated remote access tool, and more screens for these security analysts to look at. So everything that I'm going to talk about today can integrate into Splunk, and Splunk becomes that single pane of glass to view all of the logs across all of the different products. So you get a kind of holistic view across both your IT infrastructure and your OT infrastructure. So that's kind of what Cisco does. This is kind of my role within Cisco, is to kind of make this happen for critical infrastructure. But we're going to focus in on that zero trust part and how ISE plays its role. Before getting into technology, I want to talk a little bit about industry recommendations. What is it that our customers are trying to do? What are the problems that they approach us with? And again, a very common term in the OT space is the Purdue model. And the Purdue model would have been the starting point for many in the OT space for segmentation. What the Purdue model is really saying is, I have an IT network, I have an OT network, and I'm going to put this and call it DMZ in between. And the idea of the Purdue, and this is a simplified version of it, but the idea of Purdue is IT and OT can't have direct communication. So all of my critical infrastructure is in the OT side, all of my traditional kind of business applications are on the IT side. And anytime we need to do some kind of cross data communication, I'll put some sort of proxy in a DMZ so you can never get from one side to the other without going through this proxy. The reason they've done this is because the IT side is more exposed. So if something was to occur in IT and malware was to break out, there wouldn't be a route down to the OT. And this model has been implemented for many years now. It is a kind of industry best practice, but the way networks have evolved and the way the needs have evolved, this is no longer enough. We need something a bit better. So that's led to standards such as IEC 62443, which is a kind of comprehensive standard in itself. There's lots of different compliance things that you need to meet in order to be 62443 compliant. But one kind of overarching architecture that has come out of this standard is something called zones and conduits. And it's a fairly simple concept to wrap your head around. A zone is just a functional or logical or the kind of a physical relationship of devices. And a conduit is the network communication between, whether that's a switch, it could be a router, it could be a firewall. It's the way for you to route packets from one zone to the next. That's called a conduit. And the idea of 62443 is we identify assets in your zones, and then we put policies in the conduits. So if one zone was to be compromised, there's very limited communication between that zone and another zone, and you'd have to target very kind of, specific rules in order to compromise another zone. And it's a way of essentially building zones of trust, hence zero trust. And that's what NIST does. So again, 62443 is just one standard. And I get this question all the time of, I'm doing 62443, can you help me? And then another customer says, we're not doing 62443, we're actually following NIST, because NIST have publications on OT security and they have zero trust. And 62443 doesn't use the word zero trust. But what NIST does is NIST talks about zero trust using microsegmentation. And again, these are all just industry buzzwords. In the security land, we like to confuse you quite a lot. And marketing will give you a new word every year. I'm sure there'll be another name for this in the summer. But zero trust using microsegmentation is by placing individual or groups of resources on a unique network segment, and then use switches, routers, or firewalls as enforcement points in between. And all of those words is what I just described as 62443. A long story short to this is there's many industry standards in OT, and they all sort of say the same thing. If you follow good security principles, if you identify your assets on the network and you create smaller zones of trust throughout the OT, you're going to meet most of what all of this industry is asking you to do. They're just going to word it a little bit differently in their documentation. In the OT network, however, we don't really have a foundation to build on. So we talk about microsegmentation and zero trust and 62443 and these things that sound great in paper. But if you don't have 15 years of segmentation as a foundation, it's very difficult to just do microsegmentation tomorrow. So for some of you who are looking to implement this, listening to this call, you may have a Purdue model approach. You have an IT network, you have an OT network, and you've put a firewall in between. And that's that's your starting point today. For you to get to the next phase beyond IT-OT separation, these are the kind of three very high-level steps you're going to need to take. The first one is something called virtual segmentation. So I'm an IT team, I'm an IT leader, and I've inherited the OT space. I've been asked by compliance, whether that's NIST2, whether that's, I need to do something on the TSA directives, but I've inherited the OT because my compliance tells me I need to. You need to understand what's on the network. We're going to call that virtual segmentation. Virtual segmentation is visualizing the zones and conduits and then reacting to the data that you observe. So if I have a large plant and there's 5,000 devices, I'm going to use a network discovery tool. We'll talk about this in some slides. And I'm going to virtually group my devices using my visibility, and I'm going to understand what the zones and conduits model would look like before I implement any policy. You're then going to take that approach and you're going to say, I virtually segment my network. I have a good understanding of what I'm trying to do. And I'm going to take a first step of called macro segmentation, which is I'm going to do large zones in my OT network and push policies across kind of these macro boundaries. If you think of a manufacturing plant, many manufacturing plants have large production lines. They have many production lines. You might have a manufacturing company who creates, it's like a bottling company, and to push more bottles from out the door, they'll duplicate those production lines. So they might have 10 production lines all running in parallel, all just churning out the same material time and time again, 24/7. Those production lines from a networking point of view can be completely isolated from each other. That's macro segmentation. So I'm going to do things across production lines, across large zones, across buildings, and I'm going to find that kind of routing point in my network between them. I'm going to build some policy. And then we have something called micro segmentation, which is what we all strive to do. It's what we all see in the presentations. It's the nirvana of where we're trying to get to. It's essentially pushing policy across smaller zones. So within the production lines, how do I segment things? So when one thing goes down in line one, the rest of the line doesn't get affected, or at least doesn't get encrypted if it's ransomware. So virtual segmentation, what is it? How do we deal with it? Virtual segmentation is that it's visibility. So how do we get visibility of what's happening in the plant floor? I mentioned earlier on in this call that Cisco have a product called CyberVision. It's our starting point for visibility in the OT. And the reason why we need a dedicated visibility tool in OT versus what we do in IT is you don't really get much information by looking at the ports and the IP addresses that exist in OT network. There are protocols that use standard ports, so I can tell you, because I do it all the time, Modbus is port 502, Ethernet IP, which is what Rockwell uses, 44818. These things are kind of memorized and ingrained in my brain. But just because something communicates in that port, it doesn't really tell you much about what it is. So you have to do deep packet inspection. You do deep packet inspection on these protocols because within the protocol, you'll understand what the device is. Certain communication will tell you the model numbers, the firmware versions, and the type of information you need to profile a device. For those of you familiar with ISE, you can probably see where this is going. But CyberVision is going to profile everything that is on the floor. The unique thing about CyberVision, because Cisco being a networking company, is we can do that deep packet inspection within our own networking infrastructure. And that's really important for an ICS network. The reason why it's important is the devices that we're trying to detect are deep in the network. A lot of the time, they stay inside the cell area zones. They don't traverse to the internet. They don't go to the cloud. They're not trying to reach back to data centers. They're typically control loops that happen within the machines or within the lines. And in order to see the traffic, you need to be down there where the traffic is. Doing span in an industrial network is very complex, very costly, and you have two options. You do ORSPAN, which is you use the existing infrastructure, which could add additional kind of jitter and latency to critical control traffic. We don't want to do that. Or you do an out-of-band collection network, which means we're putting in more cabling, more sensors, more power, more hardware. And what industry is trying to do is virtualize all of their compute. They don't want to deal with the additional hardware. So they end up just accepting that they can only get visibility higher up the network. What Cisco allows you to do is get deep into the network and do deep packet inspection close to where the devices are to truly understand what it is that we're actually trying to protect. I'm going to actually show some of this in a demo, so I'm not going to spend too much time on these screens, but essentially what CyberVision is giving you is just the asset inventory and the profiling of everything on the network, all of the communications and the relationships of those devices, the vulnerabilities on those devices, so if we have any kind of high-risk devices in our network, and all of this can be wrapped up in a baseline so you can understand changes on your network. So we're going to see some of this later on when we get to the demo portion. And again, just for that kind of completion of PowerPoint, we'll also see, some of these screens, asset inventory, communication maps. But you can kind of see the level of detail that we have about the devices. Not only do we know it's a Rockwell device, not only do I know that it's speaking Ethernet IP because it's on the right port, but I can see that there was a stop CPU activity tags if you zoom in for that, red little tag that you see under activity tags. You can see the firmware version. Again, I'll highlight all of this when we get to the demo and you'll be able to see it a little bit better. But we tell you everything that we see through deep packet inspection. And vulnerabilities are extremely important when it comes to segmentation, because as I mentioned earlier, if you have 5,000 devices and none of them have been segmented yet, how do you know where to start? Because you're not going to go and roll out a project and segment your whole network in one fell swoop. You might look at the most critical devices in your network and say, are there any vulnerabilities that I need to take care of today? Is there any firewall rules I need to adjust? Is there anything I need to do to make sure that these devices can't be exploited over a network because there is a vulnerability CVSS of 9 and it can be exploited remotely? So these are the type of insights you'll get and an associated risk score. And from a segmentation perspective, what we're really trying to get to is how do I implement policy on this network? So IEC 62443 has the zones and conduits model, and I said we need to do virtual segmentation. Well, this is what CyberVision can do. Now that CyberVision understands all of the devices on the network, you can see that here's my Siemens PLCs and IOs, here's all my Windows devices that communicate with them, here's kind of some safety systems. You will group them up into whatever way that you require. So it's really up to you as a customer. How do you want to segment this network? Do you want to go line by line? Do you want to do kind of process by process? Building the zones and conduits is something that we can kind of guide you through in CyberVision, so you can see what do my zones look like and what the relationships between those zones end up being, because these are the policies I need to build. I can see a line between my SCADA systems and my motor control, so I know if I want to implement that in policy, well, I need to allow some communication. There's other zones that have zero communication, so they should be denied. If that manufacturing IO zone was to be compromised, there's no path for it to go and compromise cell 19 and all the subsequent zones ahead. So that's what virtual segmentation is. Nothing here is being deployed. What we do from that is then network as an enforcer. Again, if you come to my session at Cisco Live, we'll also show how to use firewalls and how this context moving to firewalls, but how do we use the network as the enforcement point with all of this data? To do that, I'm going to go through a case study. There is, customers we've walked this path down on. One of them was an automotive customer. They had the luxury of being a greenfield, which means it was a brand new plant. The electric vehicle market has kind of enabled that. A lot of these automotives have built brand new plants. And they had a brand new facility, a couple of brand new facilities with all Cisco switching. Cisco IE 3400, which is one of our rugged switching that supports TrustSec enforcement, and Catalyst 9300 at the distribution. Again, another TrustSec capable switch. And they're using both CyberVision for visibility and ISE for segmentation. So I'm going to go through that case study and the type of design considerations that we made whenever we did this with them. The first thing that they did is they came to us with a set of use cases. They said, this is what we need help with. So security is a very broad term. Said, I need you to help secure my industrial network. It's, can mean a lot of things. We were very fortunate with this customer that said, these are the 9 things that we're trying to do. How can you help us secure? The first one was all devices within a zone can communicate freely. So again, following zones and conduits, they're defined zones. They have no segmentation inside the zone. The second rule was it was a deny by default across zones. Something rare within OT because we're so afraid of putting policy between things, but they had acknowledged that they were going to define very clear zones. And by default, you can't go from zone 1 to zone 2 unless I explicitly allow that communication. The third one is that they have users that need to access these devices. So they need a convenience port that allows users to access devices within a zone. They have engineering workstation throughout the plant that were assigned to designated zones. Those workstations may have been to one zone, or there could have been a workstation that could talk to 2 or 3 zones. So they had different requirements. There were sub-users. So no matter what we did, no matter how secure we try to be, there will be users in these organizations that can access everything. So we need to make sure that those users are very secure, but also limited. You don't want all of your users to be super users. There's IT infrastructure that has access to everything, but it should be restricted. So think of radius servers, think of NTP, DNS. I don't think they were doing DHCP in this case, but they will be for user laptops. But things of that nature, the very defined and strict list of ports. There are vendor applications to specified machines. I don't think they were using them in this case, but FANUC are quite popular robot manufacturer. So think of FANUC robot arms on a plant floor, and the FANUC application needs access to the FANUC robots. Between zones, there is communications of named devices. We often call this interlocking PLCs, as a term you'll hear quite often. I think of a conveyor system. So a conveyance system normally starts with raw materials, and it's the same conveyance system that gets you all the way to a packaged good. And across every single process, there is PLCs controlling the conveyance system. If there's a failure at one part of the line, typically the conveyance system sends messages back up to the previous steps to say, stop sending me goods, I cannot accept them. And everything does a temporary shutdown behind it until that problem is solved. So there is cases where devices must communicate across zones, and then also remote users. So remote users are out of scope for this. It's secure equipment access. We don't really do much in ISE here, at least for this set of use cases. But for the rest of them, they're pretty much all in scope for ISE. So what we proposed is using SGTs, security group tags. And again, this is an ISE webinar, so many of you probably don't need this slide. But SGTs, for those of you who are new to it, is role-based access control within the network. And it's simply just a way to identify who you are, what role you have, without understanding what your IP address is, your MAC address, or any sort of networking information. So as a user, let's say a contractor or as a robot arm communicates on the network, they have a number, an identifier that's put inside their traffic that says, this is the role that I belong to. And when it tries to reach a destination device, we'll know what the role of that device is. And then every switch in the network that participates will have policies built into them to say, are you allowed, are you denied, are you something in between? So can this vendor application or can this contractor reach out to the FANUC robot that's on my plant floor? And the SGTs are basically just identifiers that we can use in policy. And the great thing about security group tags is they have a perfect relationship with the 64/3 zones and conduits model. Because for every zone of my network, I can have a corresponding SGT. So that virtual segmentation perspective, what you're really viewing in cyber is SGT relationships, that I have a group for line 1 and a group for line 2 and a group for FANUC robots and a group for whatever it is that you build. And I can visualize the conduits between those SGTs, which allows me to then make the TrustSec matrix. I'll talk more about the TrustSec matrix later on, but this is the kind of one-stop shop for all policies across the whole OT network. And again, we just have that kind of synergy between the compliance standard and the implementation. Other key concepts I do want to talk about in TrustSec is something called classification, propagation, and enforcement. The SGT is just an identifier. It's just a way for us to say, here's the role that this device has in the network. But the first thing we have to ask ourselves is, how do we classify? So classification is just assigning the SGT to the device. How do we know which tag to give that robot arm and which tag to give all devices in line 1? We then have enforcement, which what we're going to talk about today is switch enforcement, but SGTs aren't exclusive to switches. So you can use an SGT on a firewall, as an example, or our Cisco industrial routers, as an example, like used out in field networks, can use SGTs in their firewall rules. The SGT itself is just an identifier, and then the switches in this case are enforcement points that can use the SGTs in order to put access control lists in between them. And then the last thing is propagation, because we classify an SGT at its source, and then we need to figure out how that SGT then propagates throughout the rest of the network. Essentially, how do we get the SGT to the destination device? How does the destination device even know the context of the SGT that is assigned? So those are 3 kind of keywords that I'm going to use throughout the presentation. So first thing in this case study is something called the TrustSec domain. The TrustSec domain, I'm going to oversimplify it massively, but the way I look at the TrustSec domain is essentially your enforcement domain. So where is it that you want to enforce traffic? Because there's a misconception that you need a full Cisco network to do TrustSec. That's not the case. It's the ideal case in best case scenario, and in this case study, that was the scenario we were dealt with. But you don't have to have a full Cisco or a full TrustSec capable network to do TrustSec. You define the TrustSec domain where essentially you want to enforce policy. From an IEC 62443 perspective, you might decide that the cell area zones are off limits, and you only want to do segmentation across zones, while your TrustSec domain would result in the core and the distribution switches for the plant. And that can simplify things, or it can just give you a starting point to segmentation. So a little bit more on that later, why you would choose to do this, but yeah, your domain doesn't have to be the full network. And the first use case is all devices within a zone should be able to communicate freely. So in this specific use case, we didn't need the zones to be part of the domain, but there's reasons for that later on. And kind of how then do we still use TrustSec if your full domain, if your full network isn't a TrustSec domain? This is where that keyword propagation comes in. So propagation is what happens normally after classification, but I want to talk about it first. And there's two ways to do propagation: inline tagging, or there's something called SXP. Inline tagging is when you assign an SGT to the network, and throughout the life cycle of that packet, the SGT will exist. So the zone 1 switch assigns an SGT, and by the time the packet reaches the distribution switch, which is going to do enforcement, the distribution switch just reads the SGT from the packet. Fairly simple. But what happens in OT is when they're not using Cisco switches, or maybe using older Cisco switches that aren't capable, we use something called SXP. If you want to do classification based on device profiling, again, I'll explain that in the very next line, you need to authenticate the device. So when a device connects into a switch that is capable of doing radius, it will authenticate the device. ISE, based on its profile, will say this is an interlocking PLC. Again, we'll explain how we make that decision in a minute. You'll see it in the demo. But we found some magic to know it's an interlocking PLC. We push that back to a switch. The switch itself isn't capable of doing inline tagging. So what do? We do SXP to the TrustSec domain. It's just our way of saying, distribution switch, you don't know what happened during the authentication attempt. I know what happened. This IP address authenticated to me. It has SGT4. When you see this IP address, please give it SGT4 and then continue as per usual. So that's our workaround of how we deploy in OT environments without necessarily updating the full networking infrastructure. And this is kind of good for those brownfield environments where you can maybe only update the central part of your network in order to be TrustSec capable. Okay. Classification, which is where I normally start, then is how did I get that SGT in the first place? What decision tree was made in order to even know how to give an SGT to the device in zone 1? The most basic thing that we can do in an OT network is static classification. And we do this in IT sometimes as well. There may be more advancements in the data center space since I've last looked at it. I spend all my time in OT. But typically for an SGT, we might just do static classification to servers in a data center. The same thing can be done in an OT network, where you have a production line, a cell area zone, something that is bolted to the floor and never going to move and has a defined subnet, VLAN, IP range. We can just statically assign that whole production line, that whole zone with an SGT. And then so the static classification options we have are the ones that you see listed on the screen. And we do that on ingress. So we don't worry about SGTs down in zone 1, zone 2, but from a distribution switch perspective, the thing that carries traffic across the manufacturing plant, we can statically assign an SGT just based on your networking information. Dynamic classification is where we get into more of that kind of micro-segmentation world. And the use case that I'm going to bring up in a minute called interlocking PLCs. How do we dynamically assign an SGT to devices in the OT network? That's known as dynamic classification. Essentially, things that authenticate with ISE and are dynamically given an SGT based on their profile. So, two types of classification. It does not have to be an either-or approach. It's kind of one misconception I see in OT all the time. When we think of micro-segmentation, suddenly we think we have to profile everything on the network. We don't. Very simple concept for most of you on the call. You're at a nice webinar, you probably know this. Authentication, authorization, who are you, what can you do? In OT, where you are matters quite significantly, more so than your device type sometimes. So we would think of this as macro segmentation. I'm an OT device in the assembly workshop. I'm an OT device in the welding workshop. What you find in OT are the exact same devices used for different purposes depending on where they are. So you might have something called a torque wrench. So it's a wrench that whenever you tighten a bolt to a certain force, it basically breaks the connection. So you can only tighten it to a certain force value to make sure it's consistent every time that they're doing it. You're using it for a different purpose in welding than you are in assembly, and a lot of times they are connected to the network because it's part of their quality control to make sure that you followed every single step of a process, especially with those things made by hand. So you need to know, is this device for assembly or is this device for welding from a networking perspective? Because from a networking perspective, they need to go and speak with different things. So you don't need to profile a device based on what it is, you profile it based on where it is, which is we don't really do that in IT anymore, but it's still a common practice in IT. And then we have microsegmentation, which is profiling the device based on what it is. So I'm a SCADA system, I'm an MES server, I'm an engineering workstation. I have a purpose that I need to be profiled for, and it doesn't really matter where I am, because that engineering workstation might be on wheels and you might have plugged it in somewhere else at one point, but that's the workstation for zones 1 to 5. I just happen to plug it into a different switch this time. Those things do need to be profiled a bit more dynamically. These things can happen and live together. You do not need to rip up all of your macro segmentation policies just to move over to micro segmentation. Zero trust for OT networks, going back to the title of this webinar, is just building zones of trust. And it might be counterintuitive to IT, but those zones of trust can be, I trust everything inside assembly, I trust everything inside welding, I don't trust the communication that crosses those zones, let me put policy in between. And then I have some devices that need to be profiled regardless of where they are. That's what I mean by hybrid macro micro, and this is the approach that we like to take for classification. Now I am jumping from use case 1 to use case 8, which does sound a little weird. I probably should have restructured the use cases, but this was the use cases 1 to 9 were the way they were presented to me, so I just never adjusted them. But use case number 8, communication of named devices between zones is allowed. So from a macro segmentation point of view, I can label zone 1 based on its subnet. I can label zone 2 based on its subnet for this specific customer. And I can deny all communication between them. But the zone 1 PLC and the zone 2 PLC, they do need to communicate. How do I do that? Well, that's where dynamic classification comes in. So when devices connect to the network, they're going to communicate with ISE, and ISE is going to establish some level of trust with that device. In an OT network, typically we allow things on the network by default because it may be 2 a.m., IT are probably in bed. We don't want to wake them up just so as production needs them. So you're going to allow things on by default, probably. If we have an endpoint profile on that device, so in this case, if we know when we profile it as an interlocking PLC, we'll give it an SGT during authentication. That SGT will basically give it all of the authorization it needs throughout the network. We're building something based on least privilege, so zone 1 has very limited privileges on the network. Interlocking PLC has a little bit more privileges, and then we do something called continuous trusted authentication, authorization, I forget which one, but we continuously verify the trust of that device. So if anything changes during its life cycle, we can give it a different policy. Whether we have to quarantine it or remove some of its privileges, we have that option. And that all sounds great in a presentation, and I could present it to you all in a way that makes it look like it's easy, but in reality, it's not. The expectation is that I'm going to tell you these are my cell 1 devices, these are my vendors, these are my contractors, and all this kind of great stuff throughout my OT. In reality, we don't know what anything is. We see MAC addresses, we see IP addresses, and we're just kind of guessing. Is this an OT device? Is it an IT device that serves the OT? Is it a known device? We don't really know. We just kind of build all of these allowed policies everywhere because we're so afraid of shutting down production. So that's where the flyback comes in to cybervision. If you really want to implement segmentation in OT networks, you need to use the visibility in order to influence that segmentation. All of the things that we learned in Cybervision Center, it can be sent over to ISE via PX Grid. And on this diagram, you can see Catalyst Center / ISE. Catalyst Center is not a requirement. SDA is not a requirement. TrustSec can live standalone in OT, and it's recommended actually to live standalone just to simplify things. But it doesn't, there's no dependency here in Catalyst Center. It's just an option. But everything that Cybervision learns is sent to ISE. All of that virtual segmentation has already been done, can now be given to ISE in order to be pushed back onto the network. So the same switching infrastructure that is giving you the connectivity in the first place is the same infrastructure that's going to give you all of the visibility you need. And now the same infrastructure that's going to give you all of the segmentation you need. One of the mistakes we make in OT quite a lot, or just in security really, is we treat problems in isolation. So we buy a box for connectivity, and we buy boxes for visibility, and we buy more boxes to segment and more boxes for remote access. Cisco's strategy really around this is how can you leverage the network as the enforcement point or as the security fabric in your network, and that's where these kind of products come together. And one of the key capabilities that really makes this happen is change of authorization. Because when I first connected that PLC to the network, I mentioned there was some magic that happened that helped you understand this is an interlocking PLC. There is no way that we know that when it first connects to the network. We might not even know it's a PLC when it first connects to the network, because all we really see is a MAC address and the DHCP if we're lucky, but basically a MAC address that's now trying to make an authentication request to ISE, and you need to make a decision. You could add that MAC address to a trusted data store if you wanted to, but now that makes IT in the loop for all of the OT workflows, which most IT teams don't want to do. So what you do is you allow that thing on the network, you give it its macro segmentation policy, so that PLC is a zone 1 PLC, it's under the guise of zone 1. And then after we learn more things about it, then we're going to change its policy to the interlocking PLC policy, and change of authorization will make it authorize to or authenticate to ISE again in a non-disruptive way, to be given a new SGT to enhance its privileges. And that's the demo that I'm going to show here now, is how do we actually link these two products together. So you're going to see a product called SEA. This was that remote access tool that I mentioned before. Again, kind of out of scope for this, but this is how we all access our labs here in Cisco. It's kind of a quick plug, but it works really well. So logging into my SEA, I need to switch to organization. The security lab that I want to get part of is in RTP. I'm here in Ireland, and it works still quite quickly. I'm going to go to my remote sessions. I have a little segmentation demo cluster here, and I'm going to use something called SCA Plus. SCA Plus is basically just client-based access, very similar to a kind of the VPN-like solution, but it just makes things easier. So I'm going to connect to my Cybervision Center. And the great thing with SCA Plus is now I have just native access to private applications. So let's get these IP addresses. Let them load up. Said it works great, but again, halfway across the world, working as best as it can. Here we go. I just won the race. Select an extra button. Nice. And Cybervision. Just make sure that they both logged in. Yeah, that one's done. Of course it is. Okay, there we go. So this is Cybervision. Cybervision is that visibility tool for OT networks, as I mentioned. A nice security alert there. Failed login attempts. Always love to see it. But Cybervision, you get quite a lot of data in Cybervision. Think of large manufacturing plant, thousands of devices. You don't want to see all that in one go. So we have something called presets. And the preset is just a way to divide your network up into smaller chunks, just so you can kind of view it in more kind of bite-sized chunks. And we also tie baselines to these presets. So if you had a preset to say, I'm going to look at line 1 or building 1 or whatever it is that you want to focus on, you can have a dedicated baseline just for that. So I have a demo preset here. And this demo preset is going to tell me things such as the type of devices that are here, number of devices, how many are vulnerable, number of activities, etc. But the most interesting view is probably the map view. It's that zones and conduits view that we have. And you can start to see what my network would look like. So we have some kind of dummy data here for, building, factory demo kilns, where you can see various different zones. But the live devices in my network is the ones over here, these cell 1, cell 2 devices. So these are the ones that are actually authenticated over to my ISE instance. And you can see I have some Siemens devices in cell 2 and some Rockwell devices in cell 1. And if I click on one of those, you'll see the information we have. So your usual networking stuff, this is my IP, this is my MAC address. Try remember this 11.200 for me. But this is the IP address, so I'll go over and check in ISE now in a minute. But firmware version, model numbers, things like things of that nature to understand what this device is. And then, as I mentioned, all of the vulnerabilities that are connected to it. So all of the information we really need to understand how risky this device in our network. This is quite a high-risk device based on the vulnerabilities, the activities that we see, and it's also in a high-impact group. So something that we probably want to take care of from a segmentation perspective. If we go over to ISE and we go look at our active endpoints, these load up. Of course, it's going to run slow. Time it. While it's loading up, because I do have a feeling for some reason that's going to bring me to a page I don't get brought to. Yeah, this one is quicker. If I look at my connected devices, you can see here's all the things connected to my lab. And that .200 that we mentioned as an endpoint profile cell 1. Because what we're doing at the most basic level is the endpoint profile itself. If I click into the device, you'll see, where is it gone? Identity group. I'm looking for, so you can see all of the things that CyberVision has sent it over here. Here, custom attributes. We have a custom attribute called asset group, and it's in the cell 1 group. So, which lines up to CyberVision, it's in the cell 1 group. So what we're basically doing here is on the endpoint profile over in ISE, anything in asset group cell 1 is going to be given cell 1 endpoint, and anything in cell 2 is going to be given the cell 2 endpoint. So if I take this 11.200 again, and I manage the group, and I'm going to move this to an existing group, I'm going to find cell 2. So now I have that one built. Here we go. Press OK, and I'll do a refresh just so you can see it visually, but it should actually happen in ISE fairly quickly. Okay, there we go. So this .200 you can see is now in the cell 2 endpoint group. So that's essentially what that integration has given us. You can go beyond just the cell information. So you can use pretty much any of this to build your endpoint profile, this cell 2 endpoint. Maybe I could do cell 2 endpoint controllers, and I look for any device that's in the cell 2 asset group. It also has the device type controller, things of that nature. But if you want to move from virtual segmentation to implementing segmentation, you've done all the heavy lifting already here. You've already identified that this device should be part of cell 1. So in ISE, we're just going to make it easy, and we're just going to basically say anything that you've done in CyberVision, we're just going to go replicate, and we're going to do it over in ISE. So that's what that implementation looks like. And the great thing about change of authorization is because that endpoint profile has changed, it's going to trigger all of the automation in the background. It's going to go to the device, the switch that authenticated this to the first place. It's going to tell the switch, I know more information about this device, authenticate to me again. It's going to see it's now part of cell 2 endpoint, and this cell 2 endpoint will be given, have a different SGT associated, essentially promoting that device's privileges. It also makes sure that the OT engineers never have to touch ISE. As much as this is a nice webinar and we are trying to say how great ISE is, OT engineers should not be ever touching ICE. This shouldn't be part of their training. It's not their responsibility. It's an IT tool. The OT engineer, however, whenever they install a device, can come to Cybervision and just move it into the appropriate bucket. It knows it's a Cell1 device. It knows it's part of finishing line. It knows it's demo clone fine. So that OT engineer has a workflow that they can work with IT in a way that they don't actually have to touch the IT tools. So that's the demo. I'm looking at the clock here. We have 10 minutes left. So if anyone is interested in learning more about this and diving deeper into the how and some tricks about the how we do enforcement, where we do enforcement, some more kind of propagation details, I said I will be at Cisco Live. There are also kind of more learning materials on Cybervision. So I've just released a brand new CVD, Cisco Validated Design. It's where we document the kind of design guidance for things such as this. So you can go to our Industrial IoT CVDs page to get more than just security. That demonstration I just showed you, I believe, is up on our YouTube channel, but more in-depth videos on Cybervision is also there. And then just the general web page on Cisco Industrial Threat Defense. This is where you'll find more on Cybervision, ICE integrations, firewall integrations, how we use Splunk, SCA, all of that good stuff. Of course, all of those ICE resources that you have. But I'm going to pass over to Rigo to close us out here and leave some time for any questions that you may have had.
Yes, thank you so much, Andrew. That was an excellent presentation, by the way. Thank you so much. Great job. I am looking at the audience Q&A, and I don't see any outstanding questions. Our amazing panelists did a great job of taking care of all of the inquiries that came in. So I think we can go ahead and close out for today. But before I do, Andrew, do you have any closing thoughts or comments for our audience before we wrap up?
No, I just I appreciate you coming here. Hopefully, some of you were not in the OT space and in here just because you want to learn about OT. But there's a lot of different things that we've been doing in IT for a number of years that do apply to an OT network. We just need to modify them a bit differently. Zero trust is something that we've been doing in IT for a long time. It does have its place in OT, but it's part of a more holistic architecture. So. Again, for those of you new, I'd start off with just the industrial threat defense as a whole, learning about visibility. And then when you're ready to make that next step to zero trust, maybe come look at this webinar again, and hopefully some of those concepts make a little bit more sense. So.
Awesome. Well, thank you so much again, Andrew, for speaking about this topic with our audience today. I hope that everyone found great value in the information and resources that we share here today. I would also like to extend a very big thank you to each and every one of our panelists for lending a hand with all of the questions throughout the event. We really appreciate it. And for our attendees, if you do have any additional questions or would like to continue the conversation about today's topic, we do encourage you to participate in our online post-webinar discussion. The link to the post is available on your Slido screen on the left-hand side. That's where you can access a handful of additional ICE resources as well. And another reminder that our short survey is live on Slido, and we would be so grateful if you can just take a few minutes to complete it and let us know how you like today's presentation. We always look forward to receiving your valuable feedback. And for those that are interested in revisiting this session, we will have the recording available for on-demand viewing within approximately 5 business days after today. And one last quick reminder that our next session titled ICE Data Connect Deep Dive is coming up on Tuesday, March 4th. And then after that, we're going to have ICE update on Microsoft Security Identifiers on April 1st. And let me get that screen there for you. And then after that, we'll have ICE certificates with Let's Encrypt. That's going to be on May the 6th. So we hope that you can join us for these upcoming sessions as well. Thanks again to our presenter, to our panelists, and to all of our attendees for joining us here live. I hope that you enjoy the rest of your day. Thank you so much, and we'll see you next time.